But one of the things that Newton thought of gravity, one of the ways he imagined it in his head, is he imagined it like a light beam, or a tractor beam from Star Wars or Star Trek, where its beam shoots out and grabs onto the other object and holds it in place or pulls it towards it. And this is the way we think about light too, this beam of light that shoots out from the sun to the earth. And so this is how gravity was thought about for about 300 years. And then this guy came around named Einstein, and he said, I feel gravity doesn't work exactly that way. I feel gravity has a different approach. It's not just this beam that shoots out between two objects, but it's actually a twisting of space. It's like we have a trampoline or a big blanket spread out between a bunch of people, and you put a bowling ball on that trampoline or that blanket, and as you do, it deforms the blanket or the trampoline, and any other object on there, like a small golf ball or a ping pong ball or something like that, will roll towards it because it's deformed the trampoline or that blanket, and it's created a dip in it, and it's pulled the ball towards it. And that's how he started thinking about gravity. Gravity didn't just shoot a beam out and hook onto the objects around it, but it actually deforms space so much, the literal space, not just like outer space, but the three-dimensional space that we live in, the fabric of the universe, it deforms that fabric so much that it creates deformations in it that other objects sink into. And that's why, like you can see here, it's like a two-dimensional representation of what the Earth's gravitational field may look like. The Earth is actually deforming the space around it so that the satellite sinks into that hole, and that orbit around the Earth is that dip that it's created. The gravitational force that holds on to is a dip around the Earth that holds the satellite spinning in that dip. And it's the same way as the sun would. The sun is so massive that it creates this huge three-dimensional twisting of space that the Earth sinks into it and spins around it because of that twisting. So it's an interesting concept, and the only way they could think to prove it would be that if it was a beam that shot out and connected to objects of mass, then light wouldn't really be affected by it. But if instead space itself was bent, then the light would be traveling along in this bent space, and it would turn and twist with this bent space because of gravity. And so in about 1915 or something along those lines, we had a solar eclipse. And the solar eclipse was important because we couldn't see the stars during the day. We couldn't see the stars around the sun because the sun's light washed out those stars. But now, with the solar eclipse, we could see the stars around the sun, and their light was coming past the sun. And what it turned out is when the solar eclipse appeared, the stars looked like they were in different positions than they should be. We knew where the stars should be, but it appeared that the stars around the sun were in different positions. And what had actually happened was that the light from those stars was passing by the sun, and the gravitational pull of the sun had warped the space in such a way that the sun traveled in a curved path and was bent around the sun. And so it made it look as though the stars were in a different position. So the gravity of the sun was bending space and thereby changing the direction of the light so that the stars looked like they're in a different position. And this is what is known as Einstein's general relativity, that the space around an object is bent, not just a beam of force that's shot out from it.